Hi, I'm OSI. In this video, I'll be talking about indices, and we are going to look at this example. Amen. How to solve this example. They show that a raised to power x all over a raised to power y close bracket x raised to the power of x plus y times open bracket a raised to power y all over a raised to power x close bracket raised to the power of y plus s times open bracket a raised to power s all over a raised to power x close bracket s raised to the power of plus x equals to 1. Before we solve this problem, we are going to look at the 3 laws of indices. Looking at this problem, we discovered that we are going to use the 3 laws of indices to solve this problem. Amen? Okay, let's go. Before we can solve this problem, we will recall these 3 laws. 1, multiplication law of indices. Multiplication law. If we want to look at multiplication law, let's write. If we have something on this one, a raised to power n, note that this is called the base and this is called index or power. Amen? Or power. Amen? Okay? You agree with me? So, you discover that we have a raised to the power of n. So, let us try to practicalize multiplication law in indices. How? Example. If we have a raised to the power of n times a raised to the power of n, note that you don't need a prophet to tell you. Why? Because this question is from indices. Amen? This question is from indices. So this implies that, look at the basis here. We have a here, we have a here, isn't it? What is operation here? Is multiplication, true or false? It implies that you are going to take one of the base, since the bases are all the same, true or false? You are going to use one of the base to raise to the powers of n plus n. That is what you are going to do. That is to say that m raised to the powers of n plus n. So if the bases are the same, in other words, if the bases are the same, you add the powers. Amen? If the bases are the same in indices, since the operation here is multiplication, you add the powers. Are you following? Okay. So let's look at assuming you are to simplify. A raised to the powers of 2 times a raised to the powers of 3. You don't need a prophet to tell you. So let's write solution. It implies that a raised to the powers of 2 times a raised to the powers of 3. This is equals to, since the bases are the same, you take 1. Since the operation here is multiplication, so the loss of indices, if it is multiplication and the bases are the same, it implies that you add the powers, isn't it? So 2 a raised to the power of 2 plus what? 3, which is equals to a raised to the powers of 5. Amen? Okay? So you agree with me. So that is multiplication law. Now let's look at 2. Division law. Amen? I hope you are following. Division law. because we want to solve this problem. So we need to know this. Is that clear? And I'm going to tell you where and where division or multiplication law is appear. Is that clear? Okay. Division law is the opposite of multiplication law. Look at this. Okay, let's look at it. If we have a raised to the power m times a raised to the power of n, it implies that since the bases are the same, you write a raised to the power of m minus what? N. Amen? Are you feeling? So, it is not difficult. Sorry. Sorry. We are talking about division, not multiplication. Is that clear? Sorry. A raised to the powers of m all over a raised to the powers of n. Please take notes. This is division. It implies that this is equals to, since the bases are the same, you now write a raised to the powers of n, since it is what? Division, minus n. This is the final answer. Amen? So let's try with this example. Simplify a raised to the power of 2 all over a raised to the power of 3. Let's write solution. Amen? Solution. Our a raised to the power of 2 all over a raised to the power of 3. This is equals to. Note that sometimes it will not come in this way. This is the same as a raised to the power of 2 divide a raised to the power of 3. Is that clear? So it means this and this are the same thing. Since we are talking about division, amen? We are talking about division. It implies that the powers, we are going to subtract the powers. Are you following? We will subtract the powers. Is that clear? So let's write 1a, since the bases are the same. A raised to the power of what is here? 2. Since it is division, it will now be minus 3. Then this is equals to a raised to the power of 2 minus 3 will give us minus 1. And this is the same thing as 1 all over a. It means you leave it like this or you leave it like this. They are all the same thing. Now, let's look at the list. You know, I told you that we are going to look at 3 laws. I mentioned multiplication law, multiplication law, division law, and power law. So lastly, let's look at power law. Amen. Let's look at power law. Let's look at power law. 3. Power law. Amen. Power law. Okay. Power law is if we have indices of this form, a raised to the power of m, all in brackets, a raised to the power of n. This implies that this is power and this is another power, 3 of us. So this is the same thing as a raised to the power of, you use this power to multiply this power. It means a raised to the power of m times n, which is the same thing as a raised to the power of mn. Amen? Okay? So let's try with one example. Simplify a raised to the power of 2 all in bracket raised to the power of 5. You don't need a prophet to tell you. With this example, this is a raised to the power of 2 all in bracket raised to power 5. This is equals to. It means you will use this power to multiply this power. Are you following? So if you agree with me, it implies that this is a raised to the power of 2 times 5, which is equals to a raised to the power of 2 times 5 is what? 10. Do you agree with me? So with these 3 laws, I don't think idiot will be difficult for you to show. Note that this is equals to 1. Show that the left hand side is equals to 1. So let's look at this problem. Amen. Okay. Am I doing this side? Okay. Yeah. Let's look at it together. With this explanation, let's look at it together. Then, before I solve this, let's try solution. Let me just open your eyes to know something. Assuming we have a raised to the powers of x all over b raised to the powers of y, then all over raised to the power 2. Please take notes. Is that clear? Because I want to do something. That is why I'm introducing this one, so that you will not find it difficult. This implies that this power affects both the denominator and the numerator. Are you following? So it means this is the same thing as a raised to the powers of x all in bracket raised to the power 2 all over b raised to the powers of y all in bracket raised to the powers of 2. Please take note. So by the time you apply power law, both top and bottom, it means here will give you a raised to the powers of x times 2 will give you 2x. True of course. And b raised to the powers of y times 2 will give you b raised to the powers of what? 2y. Are you following? So please take note of this. And with the help of this, I don't think this problem will be a difficult one. Is that clear? Can I clean it? Okay? Okay. So let's look at it. Amen? Okay. So without wasting much of our time, let's begin to resolve, solve this question. Show that this left answer should be equal to the right answer. Simple as ABC. It means, look at this question. You discover that this question involves the three laws. True or false? It's true. It involves multiplication law. Look at it here. Look at the multiplication. It involves division law. Look at division. Look at division here. It involves power law. Look at power. Look at another power. Look at it here. Look at it here. Are you following? So if you agree with me, it means what we will do with what I have showed you. It means this is how this equation will look like. It means a raised to the powers of use x. Okay, let's, for the sake of manuals, let's do it this way. All in bracket x plus y, amen. All over, yeah, all over a raised to the powers of y, all in brackets x plus y, close bracket. Please, manuals, please take note. There is difference between a raised to the powers of x, all in bracket x plus y. True or false? This is different from this. This is a raised to the power of x, open bracket x plus y, close bracket. I feel please take note. So don't write it this way. Okay? So if you agree with me, we have done with this part. What we have here, times. Times, let's look at this. Okay? The same thing applicable, use this numerator, that is a raised to the power y, open bracket times s. All over the same thing, it will affect a raised to the power of s, all in bracket y plus s. Amen? Times the same thing applicable, a raised to the powers of s, amen, all in bracket s plus x. All over a raised to the powers of x, all in bracket s plus x, amen, then equals to 1. Okay? So let us open Amen. If you agree with me, this is a raised to the power of x times x. It will give us x squared, then plus x times y. It will give us x y. Are you following? Then all over. You know, multiplication is commutative, so one can even write yx, no problem here. But one can still write xy, no problem. Is that clear? So please take note. Okay? So if you agree with me, the same thing applicable here. A raised to the power of y times x, it will give us xy, anyhow you want to write it, or yx. Xy plus y times y, it will give us y squared times the same thing applicable, a raised to the powers of y squared plus sy or yx, anyhow. Then a raised to the powers of x times y, sy, plus s times s, it will give us s squared times a raised to the powers of this one times this, it will give us what? S squared plus sx, all over the same thing, times x times s is ss plus s squared. Amen. This is equals to 1. Can you see what I am saying now? Amen. Okay. So what is there is you are going to apply at this point. We will apply laws of division. That is division law. Is that clear? Division law. Is that clear? Here too we will apply division law. It means this denominator will come. Then since the bases are the same, so it will be minus. Okay, let's look at it. Okay, together. So here will now be a raised to the power of x squared plus xy, amen, minus, put brackets. Are you following? Try and put the brackets. Since we are applying laws of division, laws of indices, it means here will be minus. Is that clear? Minus xy plus y squared, amen. The same thing applicable here, times a raised to the powers of y squared plus sy, not 5, please take note, sy minus the same thing applicable, which is sy plus s squared times the same thing applicable, a raised to the powers of s squared, amen, s squared plus ss minus curly bracket ss plus x squared, which is equals to what? 1. Okay? So I'm going to stop here. In our next video, I'm going to complete this remaining part. Just subscribe. Thank you and God bless you. Make sure you share this video. Make sure you subscribe. Try and help somebody. Thank you and God bless you.